So, just make the form larger and make it more clear. What's really today? So in my DOM, I have my turkey, and it's located at so my turkey is over here. This is my turkey here. Okay, it's extended by PEM and it is permission. Okay, so then I just change the mode to CH mode command to make it 400, put that to 65, and then I just run the Ubuntu. I should change the user to Ubuntu, add something. So let's come back here. Let's come back here and so I do have, this is the instances that I made. Let's go again to dashboard and see the features of that. The running instances is this guy. And this is the public VLNs which I should use. Yes. So here. So say yes. So you can see that I'm in my server now. Yes. In my Evo OS, it is Ubuntu. Actually, I'm using OS, but change that to Ubuntu. And this is the version origin that now I'm in that. I don't have anything here. Yes. And just name something here. Suppose that I want to have a Python file as an example. Okay, I can run. Can I run this Python file here? Before I do install the Python in that, no. But Ubuntu does have it, yes. So that's fine. Let's skip this kind of thanks for the next session and continue to provide you with the models. So the other conventional clouds are Google Cloud Platform. It provides you with free instances as well. Just if you're curious about it, go and check it. I strongly suggest you guys to do that because it provides you with the idea of what's going on between the cloud providers. Rackspace, it's a private cloud. You should pay for that. So let's, but you can download OpenStack and you can play with OpenStack as a free cloud manager software. And Microsoft Azure as well. So you can go there and create an account and get the benefit of your account. Okay, so here I just provide what's going on in the Amazon. So it was me. Okay, I do access to these cloud web servers that is hosted by Amazon. And suppose that these are the request queue that provide with many users, or even me, but with a lot of instances. Actually, you did see that I can have more than one instances. Yes. And Amazon S3 is for storage of the file, and this is my servers. One of the project that we are, one of the codes that we're doing in our robotics robotics project is storing the image of the robots in the Hadoop. So far we are good in that. So actually we don't use Amazon, we use OpenStack in our local cloud in the AFO. So you can see that it's a consequence of the task that makes sense what's happened in the cloud. Okay, as a user, it's just enough to know this view. Okay, if I want to run a code in the cloud, it is what's going on. If I want to store my file, I should go for S3. If I want to continue a computation, I should go for EC2. Okay. So I try to provide you with a view of taxonomy of the cloud nowadays. Actually, I didn't provide it. I searched in the internet and one of the websites provides that. I was looking for that for one time. Here is the cloud softwares managers. Okay, OpenStack is in this kind. It is not mentioned here, but it is ahead of these guys because nowadays it is worldwide. Yes, it is international software that anybody can contribute to that and can proceed. So for infrastructure services, these are the provided. For storage, Amazon S3 and Amazon EBS. We do have two data sets. If you want to run a machine learning on Amazon, it asks you which service you want to host your data, S3 or EBS. Okay? You remember that in the storage properties of our instance, we have, it is mentioned that in our free instance, we are using EBS, yes? You remember that? Let's come back to it. So, and for other service managers, for compute, we have EC2 on top. For platform services, we have these companies that provide us the platform. And we have discussion about its database, yes? Google Bigtable, Amazon SQL Database, Microsoft SDS. These are the companies that if you are dealing with a big project, you should get the advantage of these databases in the cloud. And software services. We actually are just dealing with infrastructure because the project that I'm doing needs the accessibility to not only a software, to a hardware as well. So I'm looking for the infrastructure services that are provided by the companies. And I prefer the ACE and OCI Cloud to deal with what I want to do. Okay, any questions so far? These are just general information that you can have it and see if you want to do some infrastructure service or software services, which company you should search in the internet and make the account, and you can compare which one is much more expensive or much more useful for you. Okay, now let's move one step further and go for some applications from the cloud. Now we do have access to the cloud, the powerful computation engine, but what we want to do? The cloud robotics, cloud and big data, cloud and machine learning. These are the hottest topics nowadays in the cloud. And there are a lot of videos around these three topics. In the first picture, you can see that if you know, we have two connections in the robots, machine to machine, or the other one is what? Machine to cloud. Machine to cloud, that is novel now. Yes, and you have it here. Actually, previously, when we want to have a network of robots without the cloud, without the server, these swarm of robots should handle a lot of tasks between them. So, and the power, the computation, and our networking of them were so limited, and they couldn't handle all the tasks. We do have some implementation of the advanced filter algorithm previously, but they're very limited by the limitation of the robots. But by the help of the cloud, because you can see the connection between the cloud and the robots provides us not only the machine to machine, but the machine to cloud as well. So we can get the advantage of the powerful. We can offload some tasks to cloud to do that, such as VSLAN that requires a lot of computation, and other machine learning algorithms such as data analytics by the data that are gathered in the network of the robots. The second one is we're going to deep further for each of these. So cloud and big data. You know, big data, you cannot store it in your local machine. Even if you do have a 3 terabyte, 4 terabyte, or even 10 terabyte, when you want to open that kind of data, your memory or CPU doesn't allow you to do that. You know, because even we do have a storage, this amount of data should be cached in your computer at first. But your computer usually can't handle that amount of data. Yes, there's some technique that you can make a portion of portion and portion, and but the performance of the process is great if you do that. The best thing is that you have the data in the same place that you want to compute. The hidden advantage of the cloud is you can bring your computation beside your data. It is not necessary to move your data to your computing gene. Yes, it's a power of the cloud as well. The third one is cloud machine learning. You know, TensorFlow, as I mentioned by the Google, handled by the Microsoft, are the tools that are released recently, and a lot of science and a lot of research are going on around them to improve them, to make them more advanced. And on the other hand, there are a lot of scientists and engineers are get benefit of these tools. They implement the task on top of them. Next week we're gonna review some of them. So to get more detail about the cloud and robotics, we have 3 more common topology of the cloud. Peer-based model. In that model, each robot is assigned to the cloud, the virtual machine in the cloud, and you can see we do have not only a network of the robot, but a network of the servers and robots. The second one is a proxy-based model. When we want to make it more secure, usually we have one leader, yes, that we expected it to handle more capability, and then it's connected to the cloud, and then it's connected to the other side to other robots. Then there's a bridge between the cloud and the network of robots, and we call this topology as a proxy. The second one is cloud-based model. What is the difference between the cloud-based model or peer-based model? Peer-based model is what is handled by the cloud, and the computation is done by the cloud. The robot is just a mechanical thing. But when you cloud-based model, it means that you provide your robot as a friend, and you provide cloud for your robot as a friend. And some tasks can be handled by the robot, some of them can be handled by the virtual machine or cloud, and you can handle a lot of flexibility among them. So, interoperability, mobility, and robustness are compared in this table. And as you see, in the cloud-based, The disadvantage is the mobility. Usually we are looking for the mobility when you want a swarm of robots, yes. We want to have the powerful team that handle a task that cannot be handled, or it is dangerous for the human to handle them. When I compare them, I make the decision peer-based topology is the best one. Why? Because the robustness is medium, the interoperability is medium, and mobility is high. So the average is high. Any question for this slide? No? So let's come back to the second application of the cloud nowadays, the big data. What is the big data? Big data has five features. Actually, sometimes it is mentioned 6, but I don't bring the 6th one. And within this five, the first three, the 3D are really important: volume, velocity, and variety. We have a huge amount of data, the volume: terabyte, petabyte, exabyte, and zettabyte. You know, nowadays we are dealing with zettabyte. Your HAR maybe is in terabyte, zettabyte. You can Google how much zettabyte is. So, about the velocity, what does velocity mean? We have two kinds of processing: batch processing or real-time processing. Okay, batch processing means you store the data and you process on them, but real-time processing means you're dealing with the data at the same time that you're streaming them. Okay? So nowadays, when you want to figure out, do we have a credit fraud or not, you are dealing with the real-time application, yes? So, and how many credit card each of us has, and how many credit card could be fraud, you know, all of them makes the big data. Okay, so about the volume, the number of the card, okay, and about the velocity, because we need a real-time process. Okay, when we are streaming, we do want to process on them. So we should have a powerful computation gene that handle this kind of tasks. The variety, you know, it is not only one type of credit card. Maybe the data is from one company is different from other company. So it is unstructured. You should make them the same as each other at first, and suppose that you should make them the same, a huge amount of data per minute, and then you should stream them, and at the same time you should process on them not only a specific number, but a huge number of the data. So all these 3D makes the big data. And we can handle it, cloud computing. There are some examples, and I like the eBay one because, yeah, all of us know now what is eBay, and sometimes we buy something from eBay because it provides us with big deal, with good deals sometimes. So, two data warehouse at 7.5 petabyte and 40 petabyte. This is not for nowadays. It is for 2007. Remember. So suppose that following the Morse well. So how much increase do we have nowadays? About the IBM largest storage array at 120 petabyte. You know, it's a lot. You know, more than a lot. You cannot assume. Nowadays, we are not dealing with petabyte. We are dealing with zettabyte. It's for 2007. Nowadays, it's zettabyte. So you can imagine what's going on. So ATM. transfer about 30 petabyte of the data a day through its network. 30 petabytes. It is not a storage, it's just a transfer. You know, and that kind of information requires more technology. One of the technology that is so interesting nowadays is SDN, Software Defined Network. You know, when you want to transfer the data, you use switches, and you use hubs, and you use routers. Yes, and they are hardwares. Some of them has some programming, but not so advanced. Suppose that you want to add a layer on top of them and make the intelligent network. And this intelligent network handle, such as an example, for AT&T, 30 petabyte information. So how you can handle this kind of things? You know, if for example, AT&T want to have its own platform for handling this kind of things, it should have, for example, for 2 ranks of its BSCs. BSCs is the devices that is used in telecommunication for transfer the mobile apps and some things. You should have 1 rack of the SDN programmable, for example, something. So these kind of things, these big data, not only in one domain, in many domains, should be handled in cloud computing environment.
These storage arrays, when you're saying large, how large are we talking about? Like
Zettabyte.
no, the physical, like
How
how big?
So you remember the slides that we have mentioned the data centers?
Mm-hmm.
So suppose that much data centers, actually a rack is the size of me, a little bit under than me, and it's the same as we do have 16-inch rack, so it's something just like that.
Sure.
So that kind of things, you know.
And how much storage does a rack usually?
It depends on many things. You know, the hard drive is usually this much, and this much, 5 terabyte for this much. 5 terabyte of this much, and you can multiply it by the latitude and longitude of the rack, and it is not straightforward, but approximately we can figure out the rack can handle how much. But you should not only have the hard drive, you should have RAM, you should have CPU, and other things as well. So it is not really easy to handle that kind of data. This is your main data. You should have something on top of it to control it, you know. So it is complex. You need another things, another rack to handle some kind of these kind of things. Okay, so let's go further. I want to mention 3 platforms for handling big data. Peer-to-peer communication. MPI is the basic one. MPI is a network of the computers, I should say computers, and it can handle a transformation data between the computers, and it can handle the computation, the good computation actually. It spread the computation between its node as a computers, and it can provide us with some flexibility in controlling the number of nodes. MPI is old. Nowadays you heard about Hadoop, yes. What is the advantage of Hadoop and MPI? Hadoop provides us with the fast data access. Why? Because it is not spread between the computers, it is spread between the data centers. Okay, and it adds layers on top of each other to control the data management. HDFS, Hadoop Distributed HDFS, Hadoop distributed, I don't remember that is. Okay.
Filing system.
Is the one that can handle a huge amount of data. And MapReduce is a programming language that you can use on top of Hadoop to handle that big data management. But Hadoop has the drawback. What is the drawback of Hadoop? Hadoop is not designed for the iterative tasks, the tasks that should iterate over the data centers, over data. You know, you read the data, you process on the data, and then you should write it, and then you should read it, again process on it. Hadoop is not designed for this type of task. Hadoop get the data, process on it, provide the output. There is some technique that can do this, but it is not so good and integrate the performance of the Hadoop infrastructure. Okay. So the other things that is released by 2014 by the Berkeley University is Spark, EBAS. EBAS provides some accessibility to the memory, you know, to the memory of the servers. So it provides the flexibility to handle the data management. It is something between MPI and Hadoop, but more advanced. And it can handle the iterative task as well. So in the next week, we're going to play with Hadoop, and we run some Hadoop programs and see how Hadoop can help us. Okay, so continue that to machine learning. You know, machine learning algorithms are required a lot of computation on top of that. Nowadays, deep learning. What is deep learning? Deep learning mentioned to any algorithm that has more than one layer, and each layer is responsible for some task. Okay, so you want to extract some information from a data, such as your, you have a Facebook account, and you can see that when you upload the picture on Facebook, the Facebook can figure out who is that, yes? Actually, how it happened. It provides with a layer of networks. Neural network is one usually these companies are using, and each of them are responsible to extract the feature, and this feature can be used to draw a conclusion what is inside of this data. It is come from the simulation of the neuron of the brain. How many neurons usually we do have? 10 to 11, 10 to 12. And how many synapses do we have? 10 to 5. So you can imagine how complex our brain is working. To do that, if we want to implement something just like that, we should have a lot of nodes in each stage. Yes? So, and implementation of these requires a lot of computation. Neural network is not a new algorithm, but nowadays it is using because we do have access to the powerful computation engines such as cloud. So, any question so far? The other thing that I want to mention is programming. When you want to install a project in each of these domain or other domains, you should start with a programming language. Java and C# or C++ are the conventional language that always are working, yes. But sometimes they are so complex to implement something. How about MATLAB? MATLAB is very good, but it is not nimble sometimes, and it is not fast as we expected, as much faster as we expected. So Python and R are the common language nowadays that we can use and implement what we are thinking about, and they are free and they are so powerful. So we're going to continue with Python and R programming next week, implement them in the cloud. These are the smart machine learning algorithms that we're going to discuss it next week. And that's it.
Any questions?
Our programming comes from the SAS. It started from the statistics department, It's something same as Python scikit-learn that we're going to discuss about it later. Python has a lot of libraries. Each library is dedicated to specific jobs. Okay, so scikit-learn, for example, is for machine learning. And it provides us with the facility that if you do this code, provide you with this output, if you provide it with this input. Something as same as this library is provided by R in the other manner.